Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 2 paper from summer 2022. This paper is worth 120 marks in total, and this is the sixth video of 6. It will focus on questions 21 to 24, which account for 23 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 21. A circular wheel makes 42 complete turns each minute. Part A, how many degrees does it turn through in 1 second? Okay, so 42 turns in a minute, we're working in seconds. So that's 42 out of 60. So it's 42 turns in 60 seconds. But remember, we're dealing with a circular wheel. Angles in a circle in a full turn are 360 degrees. So we need to multiply this by 360 degrees. So I'm going to pop it in as a fraction. Hour off the fraction before I do the multiplication. So that's 252. So it turns through 252 degrees in 1 second. Okay. Part B1. State one assumption you've made in your answer to part A. So the assumption that we've made is that it turns or spins at a constant speed. Because if it slows down at any point or it speeds up at any point, then the angle, well, the number of turns in each minute is going to be less or higher, isn't it? So the assumption we've made is that the wheel spins at a constant speed. Okay. Part 2. How would your answer to part A change if this assumption was correct? Okay, so I've just said that really, haven't I? If the wheel was spinning faster, it will have completed more turns. But if the wheel was spinning slower, it will have completed less turns. So it will have gone through fewer degrees. Okay? So we're going to put here, if the wheel was spinning faster, it would complete more turns. Okay? 22a. Solve 2x add 5 equals 11 plus 5x. So 2x plus 5 equals 11 plus 5x. So we're solving this equation for our unknown variable, which is x, but here we have a term with x in on both sides of the equation. So I need to eliminate one of those, and I'm going to eliminate the smallest x term. So this is a plus 5x, and this is a positive 2x. I know that that's a positive 2x because there's no negative sign in front of it, guys, okay? So positive 2x is smaller than positive 5x, so this is the one that I'm going to eliminate. So to eliminate it, I'm going to take 2x away. So when I subtract 2x from the left-hand side, it eliminates 2x, just leaves me with the 5. But I have to do the same to both sides to balance the equation. So when I subtract 2x from the right-hand side, 11 stays as it is, but 5x subtract 2x leaves me with positive 3x. Now I've got a two-step equation. Apologies, the ice cream van's just pulled up on the street. So now I've got a two-step equation. So we're solving for x, so we're aiming to isolate the x term. So the next thing that I'm going to eliminate is the 11 from the right-hand side. That's a positive 11. I know this because there's no negative sign in front of it, guys. So to eliminate it, I need to subtract 11 because that's the opposite of adding 11. When I subtract 11 from the right-hand side, that eliminates 11 and leaves me with 3x. But I have to do that to the left-hand side. 5 subtract 11. Do this on your calculator, guys, especially if you're not comfortable with negative. So that tells us that 5 subtract 11 is negative 6. Now we've got a one-step equation. 3 multiplied by x is equal to negative 6. The inverse of multiplying by 3 is dividing by 3. 3x divided by 3 eliminates the 3 there and isolates x for me. But I have to do the same on the other side. So I have to do negative 6 divided by 3. I've got it in my calculator still. So that gives me an answer of negative 2. I don't need to write this any differently. This is going to get me the marks, guys, okay? So x is equal to negative 2. Part B. Solve 8x subtract 3x add 1 all in a bracket equals 2. Give your answer as a fraction. So this is the important part here, guys. We've got to leave our answer as a fraction because they've asked for it specifically. So we have 8x subtract 3x add 1 equals 2. So I'm going to simplify the left-hand side. Technically, what I'm doing is expanding this bracket because this is a negative 1 here. Okay, so I have 8x and then I have negative 1 multiplied by 3. So negative 1 multiplied by 3, that gives me negative 3x. Then I'm doing negative 1 multiplied by positive 1. So negative 1 multiplied by 1 is negative 1, and that equals 2. I'm now going to collect like terms, guys. So I have two x terms here, remembering that the sign in front sticks with the term that it's attached to. So I'm doing 8x subtract 3x. 8 subtract 3 is 5, so that leaves me with 5x subtract 1 is equal to 2. Now I've got a two-step equation that I'm going to solve. I need to isolate x to solve for it. So the first thing I'm going to eliminate here is that negative 1. The inverse of taking away 1 is to add 1. When I add 1 to the left-hand side, that leaves me with 5x because it cancels out the negative 1. But I have to do the same to the other side to balance the equation. 2 plus 1 equals 3. So now we have 5 multiplied by x equals 3. The inverse of multiplying by 5 is to divide by 5. So 5x divided by 5 gives me x. I've isolated the x term, but I have to do the same on the other side. So remember, 3 divided by 5. I'm going to write that as a fraction as 3 over 5. If you're not sure what it looks like, put 3 divided by 5 into your calculator and it will show you. It says to give your answer as a fraction this time, so I'm going to leave it exactly as it is. Part C. Tansy is trying to solve 1 is less than x plus 2, which is less than or equal to 5, where x is a whole number. Here's her work. So this is her working out. Ali says, you've made an error. Is Ali correct? Yes or no? Show clearly how you decide, guys, okay? So we're not just going to agree or disagree with Ali. We've got to show. So to show it, what we're going to do is we're going to solve this inequality and then see what x values we get. Okay, guys, so we have 1 is less than x add 2, which is less than or equal to 5. So what's different about this inequality, because it's a double inequality when we're solving, is rather than just having x in the middle there, we've got this plus 2. So like when we're solving normal equations, I need to isolate x, guys. So the first thing I need to do is eliminate that plus 2. So instead of adding 2, I'm going to subtract 2 because subtraction is the inverse of addition, okay? So when I subtract 2, it subtracts 2 from the middle and it gives me x. But I need to subtract 2 from both sides of this inequality, guys, to balance it. So 1 subtract 2 is negative 1, and I still need that less than symbol. 5 subtract 2 is 3, and I still need that less than or equal to symbol. Okay, guys? Now what we're going to do is we're going to check our solutions. So our solutions are between -1 and 3, but we only include the value if there is a line underneath the symbol because it means equal to. So we don't include -1, but we do then include 0, 1, 2 and 3 because 3's got that line. So x is any of those values. So when we look at this, we agree with the working out that Tansy's done, but what's different is she's included -1. Well, we don't include -1 in our solution because there's no equal to line underneath that symbol. So we've shown the working out and we're going to put -1 should not be included. You might have spotted that straight away, but when they look like this, it's worth checking the values and then you can spot why they've gone wrong. Part D. Represent the inequality x is greater than -2 on the number line below. So the first thing we need to do is mark at -2. So -2 is here. So I'm going to pop a circle above -2. And then we're going to draw an arrow for the full length of the number line, but for covering all values where x is greater than -2. So we're going up the number line here, guys. So our arrow is going to go in this direction because all of these values here are greater than -2. The next thing we need to check is our symbol. There's no equal to line underneath that symbol, so we leave our circle open, okay? If there was an equal to line, we would have to colour that circle in. Question 23. In an experiment, a scientist records the temperature y degrees Celsius of an object as it is heated for x seconds. The scientist thinks that the equation y equals mx plus c is a good fit for this data. The diagram shows his results on a scatter graph and his line of best fit. It's a scatter graph and a line of best fit. Part A. Estimate the number of seconds for which the object has been heated when its temperature is 27 degrees Celsius. So we can estimate directly from this scientist's graph because he's drawn a line of best fit, okay? So along the bottom here is seconds, up here is temperature. We want an estimate for 27 degrees Celsius. So we need to find where 27 is on this scale here. So be really careful when you're checking the scale. So it's going to be somewhere between 20 and 30. There are 10 little squares to cover 10 values. So each little square is worth 1. So for 27, it would be 1, 2, 3, 4, 5, 6, 7. So 27 is there. So we're going to use the line of best fit. Now I'm using a pen to make it clear on the grid for you guys, but please use a pencil in case you need to redraw anything at any point. So we're going to draw a line across to the line of best fit. And then where it meets the line of best fit, we're going to draw a line straight down to the x-axis. And then we're going to read off the seconds here from the x-axis. So we're going to check the scale because sometimes this scale could be different to this one. So from 10 to 20, that's 10 values and 10 little squares. So each little square is worth 1. So 11, 12, 13, 14, 15, 16, 17. Okay, so we estimate that it's 17 seconds that the object is heated for when its temperature is at 27 degrees Celsius. Part B. When x equals 70 seconds, the scientist measures the value of y to be 52 degrees Celsius. Use this information to decide whether the line of best fit is likely or unlikely to give reliable predictions for values of y when x is greater than 50 seconds. Likely or unlikely, explain how you decide. So we've got to use this information and we're going to use the line of best fit, guys, okay? So we're going to go back to this graph to start off with. We can't just tick a box. We need to explain why, okay? So when x is 70, y is 52. So let's go. Well, x is 70. X doesn't go up to 70, okay, on this axis. So we can't predict from it accurately. So let's think about this. 52. Well, we can estimate 52 here, can't we? So what we're going to do, we're going to continue this line of best fit so that it carries on to the end of the grid. So we can't use the 70 seconds marker, but we can use the 52 degrees marker. So let's use that. So 52 is here. So again, I'm using pen. Please use pencil in case you need to change what you're doing. But let's roughly estimate. So at 52 degrees Celsius, we're going to read across to where we extended the line of best fit, and then we're going to read down from that line of best fit. There's enough of the axes in the scale here for us to make an estimate. So that's 52 degrees Celsius. So this line of best fit tells us that it's 51, 52, 53 seconds, okay? So that doesn't match with 70 seconds, do we? Does it? So we're going to say that it's unlikely that this line of best fit can give us reliable predictions because what we've read off there doesn't match what the actual readings are. So what we're going to say here, we're going to give an explanation of the line of best fit predicts. What did we say? 50, 1, 2, 3, 53 seconds for 52 degrees Celsius. So we've given a comparison that the line of best fit predicts 53 when the actual values were 70. So it's unlikely to be a reliable line of best fit. Part C, the line of best fit passes through the points 0, 15 and 10, 22. Find the equation of the line of best fit. Give your answer in the form y equals mx plus c. Okay, so it passes through these points. So we're going to find our equation in the form y equals mx plus c. Remember, m is our gradient and c is our y-intercept. Okay, so we're going to start by finding our gradient m. So our gradient is the change in y divided by the change in x. You might have heard rise over run, that kind of thing, but the actual formula is dealing with the change in y and the change in x. So we have xy and xy coordinates. So the change, so from this point to this point, the change in y goes from 15 to 22. So from 15 to 22 is a change of 7, positive 7 because it's gone up. The change in x is from 0 to 10, okay? So the change in the x has gone up by 10, so that's a positive 10. So our gradient is 7 over 10, okay? So we can write y equals 7 over 10 x, but we need our plus c, we need our y-intercept. Our y-intercept, guys, happens when x is 0, so this point here. So we can either read it off the graph as 15, or we could recognise that they gave it here as a coordinate. When x is 0, y is 15. So plus 15, and that's the equation of our line of best fit. Part D, explain what the gradient of the line of best fit represents in this context, okay? So the gradient is the slope, and the slope of the line of best fit is telling us the relationship between the time that's passed and the temperature. So the time it's heated for and the temperature. So it's telling us the rate of increase in the temperature, guys, or how quickly the temperature increases with time. So how quickly the temperature increases with time. Question 24. So we've got a right angled triangle and it tells us the diagram's not drawn to scale, so we can't measure anything directly from it. ABC is a right angled triangle. Wonderful. AB equals 4.8 centimetres and the angle BAC is 57. So AB is 4.8 is labelled for us and the angle BAC is 57. That's also labelled for us. We need to calculate the area of the triangle ABC. Okay, so to work on the area, so the area of a triangle is the base times the height, and then we divide it all by 2, okay? So we have the height is 4.8 centimetres, but we don't have the base is BC, but we don't know what BC is. So the first thing we're going to need to do is find BC, okay? So we're looking for this length here. Now we have a right angled triangle. We have one of the other sides and an included angle. So we're working with trigonometry here, guys. We're working with SOHCAHTOA for a right angle triangle. So the first thing we're going to do is label our sides. So opposite the right angle is the hypotenuse. Opposite the other angle is the opposite. And then the side left that's next to the angle is the adjacent. Next, identify the sides that we're interested in. So we're interested in the opposite side because that's the side that we want to know the length of. We are interested in this side because we know something about it. We know that it's 4.8 centimetres. We don't know anything about the hypotenuse, so we're actually not interested in that. We are interested in the opposite and the adjacent. Okay, so when you think about SOHCAHTOA, guys, we are interested in TOA. So we're interested in this formula triangle, maybe familiar to you. So we're interested in the fact that tan is equal to the opposite over the adjacent. Okay, so we work with tan of the angle. So tan 57 is equal to the opposite side, which is x, divided by the adjacent side, which is 4.8. Now, if you're comfortable working with rearranging for algebra and solving, you can rearrange this and solve for x because we're aiming to do x equals, because that's what we're looking for. However, if you're not comfortable with algebra and solving, This is why this formula triangle comes in handy, okay? So we're looking for the opposite side. So when I cover up the opposite side, that tells me I'm doing tan multiplied by the adjacent. So I'm doing the adjacent side of 4.8 multiplied by tan of the angle that we're given. And I'm going to pop that in my calculator, guys. So 4.8 multiplied by tan 57 is 7.391351826. Okay. This, guys, is the height of our triangle. Don't forget, we haven't finished here. We need to find the area. It's not the height, is it? Ignore me. That's the base of our triangle. That's the base of our triangle. So we need to do the base multiplied by the height, which is 4.8, and then half it. So the area of the triangle, guys, we have our base, which I've left in my calculator. I'm going to multiply it by the height. So I'm going to multiply it by 4.8. And then once I've got that value, I'm going to half it because we're dealing with a triangle. So it's 17.73924438. Doesn't tell me how to round it. So I'm just going to go that it's 17.7 centimetres squared to 1 decimal place.